Welcome to Miss D's virtual classroom. Now that you've learned all the hard ways to solve quadratic functions, I'm going to teach you the easiest way. Oh, don't groan at me. I know you love the challenge. Today, you will be learning how to solve quadratic functions using the quadratic formula. Although you may think it is the easiest because there is a formula to plug all of your coefficients into, it could be the hardest if 1. You can't remember the formula, or 2. You have trouble with following precise algebraic steps and you miss a sign. Remember, you can always fall back on the other methods, especially if you are given a simple equation. So the quadratic formula was derived from using the completing the square method. A lot of people realized that completing the square was too complicated to do each time you couldn't get whole number answers, which are called rational answers. A lot of you felt the same way. So a bunch of people worked really hard in figuring out a formula that would work all the time. You can thank Simon Stebbin for obtaining the first quadratic formula in 1594, and René Descartes for publishing it in his book La Géométrie in 1637, 43 years after Stebbin. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know it seems like a jumbled mess, but you can remember it by singing to the tune of Pop Goes the Weasel. You don't remember Pop Goes the Weasel? All around the mulberry bush, the monkey chased the weasel. The monkey thought it was all in fun. Pop goes the weasel. Here's the quadratic formula version. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Try it at home a couple of times, and we'll sing it together in class first thing tomorrow. Now that you have the formula, I'm going to show you how it was derived by completing the square. And then I'll model a couple of problems for you guys. Give yourself a lot of space to write all of this down, annotating as we go so you remember what we did. Remember, the standard form for quadratic functions is y equals ax squared plus bx plus c. To solve, we have to set the equation equal to 0. If we complete the square for this equation, we first have to factor out a GCF. Since all of the coefficients are just placeholders, let's assume that there is a GCF and divide the entire equation by a. We will get x squared plus b over ax plus c over a is equal to 0. Next, we have to subtract c over a on both sides to get x squared plus b over ax is equal to negative c over a. Now to complete the square, we have to divide b by 2 and square it so that we have a new constant term. Our equation can be rewritten as x squared plus b over ax plus b over 2a squared is equal to negative c over a. Don't forget, if we add something new, something we pulled out of thin air because that's what we did in this case, we must keep it balanced by adding the same thing to the other side of the equation. So this should actually be x squared plus b over ax plus b over 2a squared is equal to negative c over a plus b over 2a squared. Ew, now this looks really disgusting. Let's simplify this ugly beast by changing the perfect square trinomial to its equivalent factored form and distributing the square. Now we'll have x plus b over 2a squared is equal to b squared over 4a squared minus c over a. Since we are aspiring mathematicians, we should always try to combine things and simplify things as much as possible. Combine and simplify this mess of fractions by using the least common multiple 4a squared as the denominator and multiply c over a by 4a over 4a. For the right side, you should get b squared over 4a squared minus 4ac over 4a squared, which we can simplify and get b squared minus 4ac over 4a squared. Since we have something squared equal to a number, we can use the square root method and take the square root of both sides. If we take the square root of both sides, we get x plus b over 2a is equal to the square root of b squared minus 4ac all over 4a squared. Remember, if we take the square root of something, we always have to have two answers. So we need to put a plus or minus here. We can't take the square root of the numerator, but we can take the square root of the denominator and get 2a. So our equation becomes x plus b over 2a is equal to plus or minus the square root of b minus 4ac all over 2a. We're getting closer. Now solve for x by subtracting b over 2a on both sides. Our equation becomes x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Again, like any good mathematician, we have to combine fractions. So we get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Voila! This is the quadratic formula. You have derived the quadratic formula.
Wow, Eliza, very nice. Great success.
Okay, now that you know the quadratic formula, let's see how we can use it. We'll start with the equation y equals 2x squared minus 5x plus 3. First, set the equation equal to 0 to solve it. Then use the quadratic formula and plug in the coefficients a, b, and c in the correct places. You should have x is equal to negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 3 all over 2 times 2. Notice that I used parentheses to indicate where my substitutions were. Doing this and writing the equation out completely will ensure that you did not miss any signs or forget to change signs. A lot of students will forget something like this, where you need the negative of b, which is the negative of negative 5, which is positive 5. So always write out the entire quadratic formula with parentheses until you are an expert. It's not worth losing points because you wanted to save a little time. Now simplify the equation and get x equals 5 plus or minus the square root of 25 minus 24 all over 4. This becomes 5 plus or minus the square root of 1 all over 4, which is 5 plus 1 over 4, or 6 over 4, which reduces to 3 over 2. Our other solution will be 5 minus 1 over 4, which is 4 over 4, and that equals 1. Here's another quadratic. Negative 20x equals 4x squared plus 25. First, set the equation equal to 0 by adding 20x to both sides. Then, using the quadratic formula, plug the coefficients a, b, and c into the correct places. You should have negative 20 plus or minus the square root of 20 squared minus 4 times 4 times 25 all over 2 times 4, which simplifies to be x equals negative 20 plus or minus the square root of 400 minus 400 over 8. As you can see, the square root portion becomes 0, and we're left with negative 20 over 8, which is negative 5 over 2. The portion under the square root has a special name, the discriminant. The discriminant lets us know how many real solutions you should have. If your discriminant turns out to be 0, like in this case, you will only have one real solution. If your discriminant is greater than 0, like in the previous example, you will have two solutions. Okay, this is the last example, and it's a word problem. First, read the prompt. This is a typical area problem modeled by a quadratic function using the information about the perimeter. To set your equation and solve this problem, you need to understand what you know, what you need, what formulas to use, and how to solve. So a good strategy to use for word problems is using a KNFS chart. Know, need, formulas, and solve. First, what do you know? You know that the perimeter is 1,050 feet and the area is 1,500 square feet. Next, what do you need? You need the lengths, which are denoted as x, and the widths, which are denoted as y. Which formulas can you use? Since this problem talks about fencing around a pasture, you can make a perimeter formula to use. There are 4x sides and 3 y sides, so perimeter is equal to 4x plus 3y. Remember, this all adds up to 1,050 feet. This problem also talks about the area of one pasture, which will be length times width. This is equal to 15,000 square feet. Now to solve, using the perimeter equation, solve for one of the variables in terms of the other. In this case, we'll isolate and solve for y by subtracting 4x on both sides and dividing by 3. Simplify like all good mathematicians would and get y equals 350 minus 4x over 3, which is the equation we want. Now to find possible lengths and widths, we would substitute our y equation into the area equation. We get the factored form quadratic function that we need to expand, which means multiply out, by using the distributive property. We get 15,000 square feet is equal to 350x minus 4 over 3x squared. Set the equation equal to 0 by subtracting 350x and adding 4 over 3x squared to both sides, because we want our leading coefficient to be positive. We get 4 over 3x squared minus 350x plus 15,000 is equal to 0. Now we can use the quadratic formula and plug in coefficients a, b, and c to find x, the length. I'll let you figure that out. And after that, use x to solve for y. Let me know what you get. That's all for today. Hope you guys enjoyed learning about how to use the quadratic formula to solve quadratic functions, and how the discriminant of the quadratic function can tell you how many solutions you should have. Your homework for tonight will be page 481. This is available to do online. Have fun, and may math be with you.